example of a relation, third part, which is reflexive and symmetric but not transitive. I have chosen a good example for it. Look at this relation, R equal to set of ordered pairs AB, such that 1 plus AB, A into B, is greater than 0 on set of real numbers. A and B are any, this R is for set of real numbers. A, B belong to R, the set of real numbers. And this R, of course, is the relation. So let me call this OK, let it be R. Now the first part, let me prove it is reflexive, to check whether it is reflexive or not. So I say A is related to A for 1 plus AB. So A into A should be greater than 0. That is 1 plus A square is greater than 0. And obviously it is whatever real number A you choose. A is a real number here, real number. So whether negative or positive, or even if 0, A square will remain positive or 0, and added 1 to it has to be greater than 0. So we can conclude yes, 1 plus, because A square is greater than equal to 0 for all real numbers. Further added 1 to it, 1 plus A square has to be greater than 0. So we say yes, the given relation R is reflexive. Number 2, to check if it is symmetric or not. Okay. So let A is related to B. That means 1 plus AB is greater than 0 where A and B are any two real numbers. Okay. Now you know in set of real numbers the multiplication is commutative. That is AB is same as BA. So if 1 plus AB is greater than 0, so 1 plus BA should also be greater than 0. Or in other words, B is related to A, and hence clearly R is symmetric. And now let me check the third part, that whether R is transitive or not. That we have to check carefully. This I would like to show because I have to prove that it is not transitive. Remember, if you have to prove it is not transitive, then even if I take 3 such real numbers for which A related to B and B related to C does not imply A related to C, even for one such set of 3 numbers, it is not transitive. So I choose first of all 1 related to half. Let's see if it is true. See, that means 1 plus 1 into half. What is the relation? That 1 plus AB should be greater than 0. Yeah, here I have taken A equal to 1 and B equal to half. I say 1 is related to half. How do you verify? 1 plus 1 into half. Obviously 1 plus 1 into half is 3 by 2 is greater than 0. That means 1 is related to half. And I also choose that half is related to minus 1. Let me check. That is 1 plus 1 into minus half. How much you get here? You get 1 minus half, that is half, which is equal to half, obviously greater than 0. So yes, 1 is related to half and half is related to minus 1. Now let me check that whether 1, A to B, B to C, that whether 1 is related to minus 1 or not, this I want to check. So if 1 is related to minus 1, what will be 1 related minus 1? 1 plus 1 into minus 1. So how much is this 1 minus 1? That is 0. And obviously 0 is not greater than 0. So if 0 is not greater than 0, that means 1 is not related to minus 1. So what do we prove? That 1 is related to half, half related to minus 1, but 1 is not related to minus 1, and hence we conclude that R is not transitive. So we have proved, the example I have chosen in such a way that the given relation is reflexive and symmetric but not transitive. Now next part is also very interesting, that we have to take an example of a relation which is reflexive and transitive but not symmetric. So I have chosen example on set A. Given is a set A consisting of numbers 1, 2, 3, 4. And I define in set of ordered pairs the relation R as 1, 1, 2, 2, 3, 3, 4, 4. Obviously that means I have chosen the case of reflexive 1, 2, 2, 3 and 1, 3. So this is the relation on set A. So I want to prove that it is reflexive. So number one, check if it is reflexive. What is the condition for reflexive? That A related to A for all the numbers in the given set. So what do you find? Yes, it is true. Why? Because 1, 2, 3, 4, 4 elements are there. 1, 1 is present, 2, 2, 3, 3, 4, 4. As 1, 1, 2, 2, that means A is related to A for all A, and hence it is reflexive. So you may write in writing that 1, 1, 2, 2, 3, 3, 4, 4, all of them belong to R, and hence it is reflexive. Okay, that you have to write. And number two, let me check that it is symmetric. Let me prove that it is transitive first, and then of course I will prove it is not symmetric, because I have to take an example of reflexive and transitive but not symmetric. Let me first prove it is transitive. Second, let me prove it is transitive. So for transitive, of course 1, 1, 2, 2, 3, 3. See, 1, 2 belong to R and 2, 3 also belong to R. So 1, 2 and 2, 3. So what does this imply? That 1, 3 should also belong to R. 1 is related to 2 is related to 3, 1 is related to 3. Yes, it is very much present in the given relation. So there is no such other case like if I take 1 is related to 2 and 2 is related to, obviously 1 related to 2. So it is transitive. R is transitive. You cannot have any contradictory case. Now, then finally, let me prove that it is not symmetric. Let's check it is not symmetric. For that, you find that 2, 3 is an element in the given relation. For symmetry, 3, 2 should also be there. But is 3, 2 there? No. 3, 2 does not belong to R. And hence, the given relation R is not symmetric. For this very part, fourth part, you may also check question number 4, question 4 and question 1, third part. Already we have proved in these two questions again that the given relations are reflexive and transitive but not symmetric. Now in the next part, fifth part, we have to prove, we have to give an example of a relation which is symmetric and transitive but not reflexive. So let us take a set consisting of symbols A, B, C, D, elements A, B, C, D. And let me define a relation R on this set A consisting of elements A, B, B, A and A. Okay, let me first prove that it is symmetric and transitive. So to prove, firstly let me prove it is symmetric. So you know clearly A, B belong to R and B, A also belong to R. A related to B and B also related to A. And A is there. So A, if you write in the reverse way, it will remain A. So it is clearly symmetric. Yes, it is symmetric. The given relation is symmetric. Now, we have further to prove that it is transitive. So second part, let me check that yes, it is transitive. You know, A is related to B and B is related to A. And what further it implies? That A related to A, yes, A is related to A. AB is there, BA is there, and AA is there. So this implies that R is transitive. Now let me check the last case, that it is not symmetric. It is not symmetric. Okay, we have proved that it is symmetric. We have already proved that it is symmetric and transitive. We have to prove that make a correction, that we have to prove it is not reflexive. Because there are 4 elements A, B, C, D, so each element should be related to itself. A is related to A, yes, A is there. But what about B, B, C, C, D, D? A, B does not belong to R. And so C, C and D, D, D is not related to D. So obviously R is not reflexive. So this is an example of a relation where R is not reflexive, but it is very much symmetric and transitive.